Everything has a why. Toss a hard little kernel into hot oil, and seconds later it explodes into a soft white cloud many times its size. You have watched it 1,000 times. But what is actually happening inside? The easy answer is heat makes it burst. True, but it misses the real trick. Each kernel is a tiny machine, a sealed pressure cooker that cooks itself to death. Crack one open, and you find 3 things: a hard, glassy shell, a dense, starchy core, and hidden inside that starch, a tiny bit of water. That little bit of water is the whole fuel of the explosion. Just a few drops, soaked into the starch, waiting. The shell is the secret. It is tough and almost perfectly watertight, far stronger than the husk on regular corn. Think of it as a sealed pressure vessel. And it does double duty. The shell is also the water seal, woven from tight crystalline fibres that keep every drop locked in until the big moment. Now heat it. Normally, water turns to steam at the boil. But trapped inside that sealed shell, the water cannot escape. So it keeps getting hotter and hotter while staying liquid. As it heats, the pressure inside climbs and climbs, up to nearly 10 times normal air pressure. That is roughly 5 times the pressure in a car tyre, packed into a seed smaller than a pea. While the pressure builds, the heat is cooking the starch soft, turning it into a hot, stretchy dough. And here is the elegant part. The tougher the shell, the longer it holds. So the inside cooks through completely before anything bursts, which makes the final flake bigger and fluffier. Then, at a very specific temperature, around 180 degrees Celsius, roughly 350 Fahrenheit, the shell finally loses. It can hold no longer, and it splits. The instant the seal breaks, all that superheated water flashes to steam at once. It blasts the soft starch outward, turning the kernel inside out into a foam that freezes solid as it cools. That foam is your popcorn. Why such a violent jump? Because when water turns to steam, it expands hundreds of times over. A single drop becomes a whole cloud, all in an instant. And that magic temperature is no coincidence. The pressure the shell can survive decides the exact temperature the water bursts at. They are locked together by physics, like a pressure cooker whose lid sets its own boiling point. It is such a tight link that big and small kernels, fat and thin, almost all pop at the same point. The size barely matters. Now, the pop you hear. That is not the shell cracking. Believe it or not, most of the cracks make no sound at all. The sound comes a few thousandths of a second later, when the trapped steam suddenly rushes out. As it escapes, it makes the hollow spaces inside the kernel ring. Exactly like the pop of a champagne cork, or blowing across the top of a bottle. In a way, each kernel is a tiny steam engine it built itself. The water is the fuel and the piston at once. It stores up energy, then drives everything outward in a single shot. So why do some kernels never pop, the chewy duds at the bottom of the bowl? Almost always they leaked. A tiny crack in the shell let the water slip out before it could build any pressure. There is a sweet spot, about 14% water by weight. Too dry, and there is not enough steam to build pressure. Too wet, and the flake comes out dense and tough. And it runs in the family. Some popcorn varieties pop nearly every kernel. Others leave loads behind. Breeders chase one number above all, how big the flake puffs up. One last myth. Popcorn is not the only corn that can pop. It is the corn built to pop. Sweet corn and field corn have thinner, leakier shells and softer starch, so they just steam and scorch instead of exploding. And the popped flakes come in 2 shapes, light, winged butterfly flakes, the tender ones at the movies, and round, sturdy mushroom flakes, tough enough to survive a thick coat of caramel. So popcorn is a tiny pressure cooker that cooks itself until it explodes. The shell traps the water. The water superheats, the pressure wins, and the kernel turns itself inside out, all in a fraction of a second. That little pop is the sound of steam escaping a machine that destroyed itself just to feed you. And it is only one of 100 everyday things hiding a why. Everything has a why. Like and subscribe for more.